In the last episode, I built a canoe from scratch using wood and fabric. Now I'm taking it to the next level. In this episode, I'll tackle the engineering challenge of converting it into a fully amphibious vehicle in preparation for my attempt to cross the Scottish Highlands and back again, one direction on water, the other on land. For this build, I used two second-hand steel BMX frames. Aluminium frames would have been ideal, however I could not find a matching pair of aluminium BMX frames in time for the build. This is the approximate configuration. So we've got a bike at the front, and then at the back here we've got two other frames. The BMX frames came with Imperial American style bottom brackets, but for this build I'll be using a metric axle from a go-kart. To make these components compatible, I fabricated a custom adapter from a simple steel tube. I used Loctite 648 to keep the adapter held in the bottom bracket. I found this beauty on Facebook Marketplace, and all that I really want from it is this back axle and some of the driving gear. A friend of mine called Euan works at ICE, a world-renowned trike company known for their incredible recumbent bikes. He generously donated a trike frame along with a seat, front boom and crankset. However, the frame was so pristine that I couldn't bring myself to chop it up, and instead I sourced a scrap electric bike from a local bike graveyard. Metals for You generously donated the stock, steel and aluminium used in this build. I designed the axle mounts to be adjustable, which would allow the canoe's ground clearance in road mode and the clearance for the pedal paddle feet in water mode to be changed. For steering, I opted for a sliding rail system instead of traditional pivoted handlebars. This allows simple and easy control in both road and water modes whilst leaving the space under the seat clear for storage. I incorporated leftover BMX and go-kart components into the drivetrain, connecting the axle to the wheels. While effective initially, this setup became a weak point when pedalling the Canoe across Scotland in road mode. The two rear BMX frames would rotate independently unless connected together. To fix this, I reused the stems from the BMXs and a steel tube to fasten them together. The final drivetrain and gearing setup featured 21 gear ratios with 3 chainrings at the front and a 7-gear cassette at the back. This configuration provided enough reduction for steep climbs in road mode and a near 1:1 ratio for water mode. The drivetrain included a 2-wheel drive system that functions similarly to a differential, allowing both wheels to be engaged when travelling straight, providing more traction. However, when turning corners, the inside wheel takes all the load, while the outside wheel spins freely due to the freewheeling hubs in the BMX wheels. This setup has the advantage of preventing torque from building up in the axle during turns, making handling easier and reducing wear on the components. On the downside, as I discovered during my return journey across Scotland in road mode, channeling so much load through a standard bike chain and wheel when turning was problematic when climbing steep sections of the Great Glen Way. I originally used the pedal paddle system during my source to sea journeys down the River Thames and the River Wye. Both journeys presented challenges like shallow water and weeds, which would damage most other propulsion systems. You can find more about these journeys in my previous YouTube episodes linked on screen. The pedal paddle system was inspired by Theo Jansen's Strand Beasts, which are optimised for walking on land. I simplified the system so that it converts the circular motion from pedalling into an elliptical/kidney bean motion at the paddles. The pedal paddle system increases forward thrust while reducing unnecessary up and down movement. This results in less splashing and more efficient propulsion when compared to a normal paddle wheel with similar dimensions. A key benefit is that at certain points in its cycle, the system has zero draft, meaning that it doesn't extend below the bottom of the canoe, reducing the chances of snagging. This makes it ideal for navigating shallow waters and areas with obstacles just under the surface. Although the boat is unlikely to encounter weeds in shallow water while crossing Scotland, except when launching and landing, I chose the pedal-paddle propulsion system because it does not require any hull penetration. This means the setup can be retrofitted to existing canoes without affecting their structural integrity. To drive the pedal-paddle feet, I fabricated arms extending from the axle using leftover aluminium bar. A local machine shop kindly rebated the aluminium, allowing me to use the spare go-kart hubs. This bike frame needs to be attached to the tip of the boat somehow, and I think I'm going to put a plate in there. So I'm going to experiment by chopping up some stock steel and then see how it feels. As the front bike connection will be sort of safety critical, I thought I'd just test my welding skills, and I'm glad I did because frankly they are shocking. Just don't know how to weld properly, so I am going to go and consult with professionals. A friend of mine called Julian runs this most amazing car restoration workshop, and he is going to be helping out with some welding. All done. What a relief to have it done properly. That is not going to break anytime soon. Back to the workshop. Connecting stiff materials like steel to flexible ones such as wood can be challenging as the joints tend to loosen over time under dynamic loads. I created an aluminium adapter piece to help distribute the loads from the front wheel bike frame into the canoe frame, ensuring a stronger and more durable connection. Fits like a glove. The real challenge is going to come with drilling these holes all the way through the width of this piece of wood. It's 8mm, so not massive and not small, but still, with a drill bit that long, it's really flexible and super hard to get straight. It's veered right off. It hasn't broke the side. I think I'm gonna let that one go. There's plenty of material there. There's some material on the side still. Starts off okay. I took the canoe to a local reservoir to test both road and water modes. While the tests were fairly successful, two issues became clear. The pedal feet needed to be much wider and a rudder would be essential. I also decided to make a sail for the boat. I decided to make pedal feet to mimic those of ducks. For the claws, I repurposed steam bent oak from a previous project and used seasoned oak offcuts and polyurethane glue to fasten them together. To reinforce the webs of the duck feet, I stretched the core of Dyneema rope between the claws and secured the ends with epoxy. For the webs of the feet, I used the same ballistic nylon fabric used for the canoe in the previous episode. I kept the fabric wet during stitching to allow it to relax and expand. After using up all of the 2-part polyurethane on the canoe's body, I opted for a water-based polyurethane varnish for the feet. KO Spruce kindly provided the 3.8 ounce sail fabric for the sail. It is lightweight enough to sew easily with a domestic machine while being plenty strong enough for the sail. I chose a sail area of around 1.2 square metres. Its compact size allows use in higher winds and reduces the risk of the canoe capsizing while packing down neatly to fit inside the boat. I chose seasoned oak for the sail battens and coated them with Danish oil. The simple mast was made from aluminium stock tubing and attached to the canoe using a flexible tiller joint, allowing the sail to be easily raised and lowered. The canoe weighed in at around 25 kilograms, which includes part of the bike frame at the front and additional oak reinforcements in the bow and gunnels. Without these extra components, the canoe would likely be closer to 20 kilograms. The main bike mechanism weighed in at just under 40 kilograms, primarily due to an oversized back axle and the use of 2 steel BMX frames at the rear. While hefty, it should hold together and leaves plenty of room for improvement in future iterations. I loaded everything up for the second test session, which coincided with press day. The wonderful teams from the BBC and ITV attended, and the project was featured on both local and national TV and radio. In the next episode, I will attempt to cross the width of Scotland, one direction on water along the Caledonian Canal and the other direction on land along the Great Glen Way. Along the journey, I will be wild camping, facing wind and waves and some brutal off-road sections with some nasty consequences.